Good morning, all of you, once again. Okay, I'm recording this lecture also, and I have been observing, girls, you are not watching the videos of the lectures. So please do watch and enroll yourself on Moodle. I cannot see all the girls. So today's topic is non-negative integer solutions. It will take 2 lectures at least to complete this topic. Okay. Can you all hear me?
Yes, ma'am.
Huh.
Yes, ma'am.
Okay. Yeah. So, what are non-negative integer solutions? Where do we use this particular concept? Suppose I have an equation, say x1 plus x2 is equal to 3. Okay. Now, first of all, do you understand the meaning of non-negative? What do you mean by non-negative? You have to answer my question. What do you mean by?
Positive integers.
Then I would have said positive integers. Why I'm saying non-negative? That means it includes 0 also. Okay. Are you getting it? So we want to find out non-negative integer solutions means we are looking for the solutions from the set 0, 1, 2, 3 onwards. Do you understand it? And particularly integer solutions. Okay, otherwise this equation has infinitely many solutions. When I write x1 plus x2 is equal to 3, it represents a line in two-dimensional plane, right? So it has infinitely
Ma'am,
many.
explain once again. मॅम कळलंच नाही नॉन नेगेटिव्ह इंटिजर म्हणजे काय?
इंटीजर म्हणजे कळतं ना
Integer म्हणजे कळतं ना तुम्हाला?
इंटीजर्स.
येस.
What are integers? Tell me.
Yes, ma'am.
What are
The set of
integers?
integers z is represented by, it is infinite set. It includes negative integers, positive integers as well as 0, right? This is your z. Now when I'm saying non-negative integers, that means I'm not including this portion. Okay? Are you getting it?
Yes, ma'am.
So
Are you
we
getting
are
it?
considering
Yes.
only this set 0, 1, 2, 3 onward. So it is also an infinite set, but it does not include negative integers. Okay. In general, if you
Yes, ma'am.
don't put this particular condition, then x1 plus x2 represents what? It represents a line in the plane. Okay, so you can have 1.5 plus 1.5 is equal to 3 also as one of the solutions if you do not put this particular condition, non-negative integer. Okay, if you consider all numbers real numbers, then 1.5 1.5 is your answer. But here we are not allowing 1.5 and for x1 and x2 variables, these values we are not allowing. We are just considering non-negative integer solutions. So how many non-negative integer solutions are there for this equation that we want to find out? I have x1 plus x2, only two variables, and their addition is 3. So can you tell me one solution from this set? If I put x1 is 0, what is x2 key value?
3.
3. So 0 plus 3 is 3. I can have 3 plus 0 equal to 3. I can have 1 plus 2 is
1 plus 2.
2 plus 1, right? I can have 1 plus 1 plus
Can
1,
have 1.
right? Are you getting it?
Yes, ma'am.
So how many, any other solution you are getting? Non-negative integer solution for this particular partition. This is a partition of number, right? You are writing the partition of number 3 in terms of non-negative integers. Okay. So how many solutions we are getting? 5 solutions we are getting. But here, if you have many variables and the number is also very big, then it becomes very difficult to list out such solutions. Yes or no? If I have x1 plus x2 equal to 2, you can immediately list out 0 plus 2, 2 plus 0, 1 plus 1, right? You have only 3 solutions. Okay. So it is 3C2. 3C2 is 3. Okay. So we are going to see the formula for this particular situation. Do you understand it? Do you understand it? Yes or no?
Yes, ma'am.
So the number 3 is very small so that we can list out it. List out all the solutions. Number 2 is also very small. We can list out actual solutions. But if I give you a number, say 355, can you list out it? Can you list out the solutions? Number of solutions?
No.
You can, but it will take your much
But
time.
it's very hectic.
Yeah, not hectic. It is very time-taking activity, right? So
Yes.
mathematics always gives solutions for such kind of problems. We should try to use formula wherever and whenever possible. Okay. So let us see the theorem which gives us formula for this. So we are looking for such kind of equation. See, x1 plus x2 plus up to xk is equal to r. Okay. And the number of integer solutions, non-negative integer solutions, are given by this formula r plus k minus 1 cr. Okay. This is the formula we want to develop. So write the theorem first of all. Write the statement of the theorem. The equation, theorem, the equation x1 plus x2 plus up to xk is equal to r has r plus k minus 1 cr solutions in the set of non-negative integers. Please remember, non-negative integers means the set of integers along with 0. Okay. It is sometimes it is written as, this set is written as z plus union 0. Z plus means positive integers union 0. Okay. This is how we write it notation wise. Now proof. It's a small proof. See, when I write 0 plus 3, then x1 I'm taking 0 times. So I will indicate the number of times x1 is appearing by n1. I will indicate n2 by the number x2 is appearing how many times, likewise. Okay. So, and then we will get a sequence of these numbers. So write proof, let x1 equal to n1, x2 be equal to n2, and so on, xk equal to nk. Are you writing with me? Because we want to finish this topic today and we want to solve one problem also. Be quick. Be any solution of the equation x1 plus x2 plus up to xk equal to r, so that n1 plus n2 plus up to nk is equal to r. n1 plus n2 plus up to nk equal to r. Have you understood this? We are just substituting x equal to n1, x2 equal to n2 and so on. We encode this solution as a sequence of finished writing, girls?
Yes, ma'am.
We encode this. Okay, I'm waiting. Complete it quickly. हो गया? We encode this solution as a sequence of n1 x1, n1 x1s, okay? n1 times x1s. Are you getting it? It is not letter S. I am saying n1 times x1s. Then n2 times I will write x2s. And so on, nk times I will write xk's as below. That is, x1 is appearing how many times? N1 times. So I will write x1, 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 and so on x1. So this is how many times I am writing. Shraddha, please mute yourself. Then I am writing x2. x2 I am writing n2 times. Okay. As many times x1 is appearing. And so on. I am going to write xk how many times? Yes, girls. How many times xk I am writing?
Nx times.
Huh?
NK times.
nk times. Okay, so we are getting a sequence. Oh, sorry, purse there. Finished writing?
Yes, ma'am.
Yeah. So each such encoded sequence is an unordered sample. Unordered sample of size r with repetition, right? We are repeating the numbers here. We are repeating x1 n1 times, x2 n2 times, and this order is not fixed. Okay? With repetition. Because ultimately you are adding them. So addition is commutative, you know that. That means, see, I can write 1 plus 3, which is same as 3 plus 1. Okay? With repetition from the k elements. From the k element set. X1, X2, we have k types of elements, right? You remember we had similar type of result? Do you remember where we had combination with repetition we had taken? And in that we had a sequence of stars and slashes. Do you remember that proof? Girls, do you remember that proof?
Yes, ma'am.
So it is similar, the same thing I'm doing here. Okay. So I'm using that here now. That I have k types of elements and I want to make unordered samples of size r. Okay. But we know that the number of unordered samples of size r from k types of elements. See, there we had k types of elements, but the number of unordered samples of size n we used to take. Okay, that was size n. Here we are taking size r. Are you getting it, girls? There we had sample size as n. Now we are having the sample size r. Okay, because we have x1 plus x2 plus up to xk equal to r, and there are k types of elements we are putting. So it is using that formula. In place of n, now we will substitute r. Okay. Therefore, the equation x1 plus x2 plus up to xk equal to r has r plus k minus 1 cr solutions in the set of non-negative integers. Okay. Finished writing? We have k types of elements and our sample size is r. Therefore, we just want to choose the unordered samples of size r from k types, which can be done in, and how it is r plus k minus 1 cr, we have seen in the earlier theorem. In combinations with repetitions, these are nothing but x1 is repeating n1 times, x2 is getting repeated n2 times, and xk is getting repeated nk times. So this is just combination. Unordered sample means combination. Selection, there is no order. In arrangement, there is an order always we have to follow. Have you finished writing?
Yes, ma'am.
Okay. Okay. Now let us see how this works in case of, now let us see a bigger equation. Okay. You will understand, which we can list out also. We already have seen that. हमने जो example लिया था x1 plus x2 equal to 3 and our answer was how much? So here, what is k here? Can you tell me what is k here? Just compare it with our equation x1 plus x2 plus up to xk is equal to r. So what is k here? X1 plus x2 we have. So what is k value here? 2. And what is r value?
3.
3. Right? How many solutions we should get then? R plus k minus 1 cr. So that is 3 plus 2 minus 1 c3. That is 4c3. So what is 4c3? Is it 4?
Yes, ma'am.
And how many we were getting? We were getting 5 now. So this one plus 2 1 plus 1 plus 1. How it is not matching?
मैम लास्ट वाला 1 plus 1 plus 1 नहीं होगा ना, 2 ही है integers.
Yes, that's what I was thinking. 1 plus 1 plus 1. Because we have only 2 types. Yeah. So the
Yes.
answer is 4. Yes. We won't have 1 plus 1 plus 1 because we don't have 3 types of elements. We have only 2 types of elements, x1 and x2. We do not have x1, x2, x3. So this will not be there. Okay, this was wrongly taken by me. Here also, no, not here. Here we will have here, because here only 2 types of elements and 1 plus 1 2 we can take. Have you understood this, girls?
Yes, ma'am.
Now in case of this equation, suppose I have x1 plus x2 plus x3 is equal to 4. Then how many partitions you will have? These are simply the partitions of number 4. Okay. Yes, can you tell me quickly? 400 we can have, right?
Yes.
1, 2. Yes.
040 we can have, then 004 we can have, right? Now likewise you tell me one by one quickly.
310
Correct.
031
Hmm.
301
0.
301
022.
022
20.
220
202.
202. Then
211.
I can have 211. इससे 3 मिलेंगे
112 112
121.
और इससे भी मिलेंगे और 3 आएंगे.
013.
Yeah, 013. You can have 013.
103.
You can have 103. One more.
130.
130.
130. Yes. How many are there now? 12. और हैं. कितने आए हमारे 2 3 4 5 6 7 8 9 10 11 12 13 14 15 15 आए, right?
Yes, ma'am.
Here also number 4 is small and the number of compartments or the number of partitions are also small. In 3 compartments you have to divide this 3, right? They divide this number 4. So that was easy to list out, but every time it won't be easy. So here what is R? R is 3. Sorry, R is 4, the number on the RHS. And K is the number of types of elements you have, that is 3. So
3.
using formula, it becomes 4 plus 3 minus 1 C4. So 4 plus 3 is 7 minus 1 6 C4. 6 C4 is 6 factorial upon 2 factorial into 4 factorial, which is 6 into 5 into 4 factorial upon 2 factorial into 4 factorial. 4 factorial gets cancelled. 6 into 5, 30 by 2 is 50. Are you getting it? So if you know the formula and if you understand it, then you can use the formula easily and get the answer for any integer. And it's not that this is useful only for such type of equations. You can have the situations where you can put the situation into this particular equation and you can get the solution. Okay. At the end, you can write this statement so that you will. This problem is equivalent to that of distributing r identical objects into k distinct boxes. Okay, यही हमने किया था, if you remember, into k distinct boxes. Okay, combinations with repetitions. So this finishes counting principles chapter. Okay. Just to summarize what we had in this chapter, we started with basically cardinality, right? Cardinality of a set. The first thing was cardinality of a set. Cardinality of a set means number of elements in the set. Okay, so that is denoted by this mod A sign. Then we had addition principle or sum rule. Okay, then we had multiplication principle or product rule. Then we had inclusion exclusion principle. For 2 sets, 2 and 3 sets. Okay, and for n sets also we had a corollary also. Then we had pigeonhole principle. And then we had permutations, combinations with repetition, without repetitions. Okay, results are based on permutations and combinations. Okay, so you should be able to identify the situation where which principle is used. Okay, that you have to understand. Do you recall all these things we have done from this chapter?
Yes, ma'am.
Hmm. Okay, so we will spend one more lecture to solve problems on this. Okay, on the last results which we had, combinations with repetitions, non-negative integer solutions, permutations of indistinguishable objects, etc. We'll spend one more lecture on Monday on problems or for problems. Okay, so that you will have no doubts. And on Tuesday you are having your test, right? You remember?
Yes, ma'am.
Yes, ma'am.
Okay, good. So we will meet on Monday.